All right, so let's go ahead and start our fourth unit of the year, and this is all about right triangles, and it's going to be a lot of fun, so get ready. So first, let's recap on what we did last unit. We did this a little bit, and let's talk about simplifying radicals. So this first part, how you solve this, it's the square root of 9 plus 36. Since those are both underneath the square root, you go ahead and add those together. So that gives you 9 plus 36 would be 45. All right, now can you take the square root of 45? No, you can't. So you have to break it up into a perfect square. Which perfect square goes evenly into 45? Well, that would be 9. So that would be like the square root of 9 times the square root of 5. Okay, and then go ahead and take the square root of 9, so that's 3. So 3 square roots of 5 is your answer, because you can't simplify the square root of 5 anymore. Okay, the next one, we've got square root of 50 minus the square root of 32. So remember, you can only add and subtract if they are the same underneath the square root. And obviously these are different because this one's a 50 and this one's a 32. Okay, since we can't just go ahead and start subtracting, we have to try to simplify first. So let's simplify 50. So 50, that breaks up into what perfect square? Well, that would be 25, square root of 25 times the square root of 2. And so that ends up giving me 5 square roots of 2. Okay, now let's do the same thing with 32. Which perfect square goes evenly? There's more than one on this, but I'm going to pick the biggest one. Let's do 16 times 2. So that gives you 4 square roots of 2. All right, so now we have 5 square roots of 2 minus 4 square roots of 2. So now you just treat those square roots, since they're the same, like you would a variable. So this is going to be 1 square root of 2, or you could just say the square root of 2. All right, next one. So this one we could go ahead and just multiply, since they're both square roots, 18 times 72, and then try to simplify. But I think it's going to be easier on this one if we simplify first. So 18, let's break that up into the square root of 9, the square root of 2. So that becomes 3 square roots of 2. Let's break up 72 into the square root of 36 times the square root of 2. Remember, we're multiplying, so that becomes 6 square roots of 2. Okay, now, so when you're doing this, you can multiply the numbers out front times the other number out front, and then the square roots times the other square root. So let's do the numbers out front first. So 3 times 6 would give me 18. All right, and now remember, square root of 2 times the square root of 2 is 2. Anytime you have the number multiplied by itself and the square root, it's just that number. So now we have 18 times 2. And go ahead and do the last bit of multiplication, which would be 36. Okay, let's go on to letter D. This one, 8 square roots of 3 squared. Since that parentheses is around the whole thing, that whole thing is being squared. So this is like 8 square roots of 3 times 8 square roots of 3. Okay, so just like the last problem, we're going to do the numbers on the outside. So 8 times 8, that gives me 64. And then let's do the square roots. So the square root of 3 times the square root of 3 is going to give me 3. So now we have 64 times 3. What is that? 192. So 192 is our answer. All right, almost done with these. This one. So on this one, if you remember, you don't want to leave any square roots in the denominator. So how you do that is what's called rationalizing the denominator. So you're going to multiply it by the square root of 2 over the square root of 2. Okay, we multiply straight across. So 6 times the square root of 2 is just 6 square roots of 2. Square root of 2 times the square root of 2 is 2. All right, am I finished? Nope. You can reduce the numbers on the outside. You can't reduce the square root of 2 and 2 because they both don't have a square root, or they're 1 and 1, okay? So they either have to both have a square root or neither one of them have a square root. So that's why we can reduce the 6 and 2. That becomes 3 and 1. So my final answer for this is 3 square roots of 2, or you could put 3 square roots of 2 over 1. All right, let's do this one. So there's a few different ways you could do this. You could divide first or simplify. Let's simplify because it turns out pretty nice whenever you do that. Okay, so 20. Let's simplify that. That would be like the square root of 4 and the square root of 5. So that becomes 2 square roots of 5. So we have 2 square roots of 5 on top here. Then let's do 500. So 500 breaks up into 105. So square root of 100 is 10. So we have 10 square roots of 5. All right, so now look how nice this cleans up. So your square roots cancel, and you have 2 and 10, which you can divide both of those by 2. So that turns into 1. That turns into 5. So your final answer on this is 1/5. All right, now that we got our recap of square roots, let's go into the actual lesson. So we are talking about the Pythagorean theorem. You've probably seen this in 8th grade when you took pre-algebra or whenever you took pre-algebra. So how you do this is you have to have a right triangle, and the most important side to mark on these is your hypotenuse, the C. So you have the formula a squared plus b squared equals c squared, and C is the most important because that's the one you for sure cannot get wrong. The A and B, those are interchangeable, so if you could say this is A and that's B, or you could say that's A and that's B. It doesn't matter, you're gonna get the same answer either way, but the C does matter, and the hypotenuse has to be the one by itself. Okay, so let's go, I'm gonna skip that part, let's go down to here. So what is the length of the hypotenuse of triangle ABC? Do the side lengths form a Pythagorean triple? Explain. So first, what is our missing side on this one? Well, it would be our hypotenuse, so that one always has to be C. So then I'm going to call this one A and this one B. It doesn't matter. Remember, you have your formula a squared plus b squared equals c squared. So I'm just going to plug it in. You have 20 squared plus 21 squared, and we don't know what our hypotenuse is, so I'm going to leave it as c squared. All right, so we're going to have 20 squared is 400. 21 squared is 441 equals c squared. Now the next step is to go ahead and combine your like terms over there. Okay, so that gives us 841 equals c squared. All right, and now, so some people will stop here and say 841 is the side length, okay? Is that a realistic number for this? No, we got 20 and 21. There's no way that would be 841. So there's one last step that you always have to take on the Pythagorean theorem. So it is how to get rid of that squared with the c. Well, the opposite of squaring something would be to square root it. So that's what we have to do. So the square root of 841, I'm going to have my calculator do this. It is a whole number. That's good. So it's 29 equals c. And that's your answer. And that is a realistic answer. And remember, like another way you can double check this is, for one, is it realistic? And for two, is your hypotenuse the longest side? If I would have gotten an answer like 15, that wouldn't have worked because I had 20 and 21 as my side lengths, and I know my hypotenuse has to be the longest side. Okay, let's go over to this one. The legs of a right triangle have lengths of 10 and 24. What is the length of the hypotenuse? This one I'm going to just sketch a quick picture, draw a little weird looking right triangle, that's fine. So the leg lengths, so that would be the sides, so 10 and 24. And then we're trying to find the hypotenuse, which is always C. All right, I'll call that A and that B, and then let's go ahead and get started. So this would be 10 squared plus 24 squared equals C squared. Okay, so then this would give me 100 plus 576 equals C squared. Go ahead and add them. So that would give you 676 equals C squared. Remember, your last step is to always take the square root and make your calculator do it. Square root of 676 is 26. We got another whole number, sweet. Okay. Next one, what is the value of x? Express your answer in simplest radical form. So simplest radical form tells me I'm probably going to have to simplify a radical, and it's not going to be a whole number, but that's okay. So let's label all of our sides. Where is the C, the most important side? Well, that's on the 20, longest side. So now you can call this x, A, or B. I'm just going to call it A, and this 8 will be B. So we've got A squared, because I don't know what it is, plus 8 squared, equals 20 squared. Go ahead and solve. So A squared plus 64 equals 400. All right, so 400 minus 64. So sorry, what would I do to get the A by itself? Well, I would subtract 64 from both sides. So you would have A squared equals 336. All right, and now take the square root, try it in my calculator, and it does not work. It gives you a decimal. Okay, so we're gonna have to break this up. That's okay. Always check to see if you can break it up. So 336 divided by, I'm going to save us some time because I know what it is. It goes, 16 goes evenly into it. And yes, it did take me a while to figure out which one went. So just guess and check if you're doing this on your homework. So 16 times 21, fun fact, is 336. All right, so now that turns into 4. Can you split up the square root of 21? It's not divisible by 4. Or 9 or 16, so nope. It's just 4 square roots of 21. So A equals 4 square roots of 21 is our answer. Okay. Next one, the hypotenuse of a right triangle has length 12, so the hypotenuse, let's just draw it again. Hypotenuse is 12, and one leg length has a length of 6. What is the length of the other leg? Express your answer in simplest radical form. So we know this one is our C. And let's call this, it doesn't matter, A, and this one B. You could switch the A and the B if you'd like, it doesn't matter. So I'm going to have 6 squared plus B squared equals 12 squared. Right, that gives me 36 plus B squared equals 144. So we're going to do, get rid of that 36 over there. So I'm going to subtract 36 from both sides. And B squared equals 108. 108, you can divide, let's see, divide by 4. Looks, there's a bigger one than 4. It looks like it's 36. So 108 splits up into 36 and 3. And that gives me 6 square roots of 3. I forgot to write the square root symbol. That's okay. There it is. So b equals 6 square roots of 3. All right, a few more. So if you want, I'm going to go ahead and pause the video. Actually, no, I'll just work them out. So we've got, pause this video and try it by yourself and then check and see your answers, but I'm just going to work them out. So we're missing our c. So that would give me 14 squared plus 48 squared equals c squared. 14 squared is 196. 48 squared is 2,304 equals c squared. All right, now I'm going to add those two together. Oh, nice. This comes out to be a whole number. So it gives me 2,500. Then you take the square root. When you do that, 50 is what your c is. Is that realistic? Yeah, sure. Okay, next one. This is my c. I'll call this a and this b. So I have a squared plus 24 squared equals 51 squared. So a squared equals, these are big numbers, so 24 squared is 576. 51 squared is 2,601. Now let's go ahead and subtract 576 from both sides. So a equals, let's see, minus 576. I'm making my calculator do it. So it's 2,025. Then the last step is to square root it. And you get a equals 45. Okay, this problem I'm actually going to change. So we're not going to do one or do that one. We're going to do something different. So if I have a right triangle, and let's say I say this side is x, this is x, and this is, let's say, 4. Okay, because there's a homework problem like this. That's why I'm doing it. So you would do it the exact same way. This is your c, your a, and your b. So my a is x, so I would do x squared, plus my b is x, so x squared equals 4 squared, same thing. Now this is where it's a smidge different. So x squared plus x squared is 2x squared equals, that's going to be 16. Okay, so now what would be the next step? Can I square root it? No, not yet. First you need to divide by 2, and this is where it's different. So those cancel, so x squared equals 8. Now you're ready to square root it. So x equals the square root of 8 breaks up into the square root of 4, the square root of 2. So 2 square roots of 2. Okay, almost done. I know this is a long video, I'm sorry. Okay, so the converse of the Pythagorean theorem says this is how you would prove that it's a right triangle. So if you have a squared plus b squared equals c squared, if you work it all out and they equal each other, then it's a right triangle. Okay? So a triangle has side lengths 85, 84, and 13. Is the triangle a right triangle? So how we do this is we're going to plug it into our Pythagorean theorem. Of course, the most important side is our c. Which one is that? Well, it has to be 85 because it's the longest side. So I'll call this a and this b. So it have 84 squared plus 13 squared equals 85 squared. So 84 squared is 7,056 plus 169 equals, what's 85 squared? 7,225. All right, so now we're just going to add these two together. 7,056 plus 169, oops, I messed up, is 7,225. So So do they equal each other at the end? Yes. So this is yes, it's a right triangle. If they did not equal, it would be no. Okay, a triangle has side lengths of 16, 48, and 50. Which one's your C? Well, it has to be the 50. So I'll call this A and B. So I have 16 squared plus 48 squared equals 50 squared. So 16 squared is 256. 48 squared is 2,304 equals, that'll be 2,500. Okay, then you go ahead and add on the left. So that would give me 2,560. So it looks like it's close, but they are not equal. So this would be a no. They are not a right triangle. Okay, so now here's this next part. This comes up on your quiz. So c squared is greater than a squared plus b squared. This is the Pythagorean theorem. If whenever you do this, like if they're equal, it's going to be a right triangle like we just did. But if it's not, and look how it's written backwards. So they write the c first. So if c squared is greater than the other two added together, it's obtuse. If whenever you do it and the c squared is less than, it's acute. So the one trick I will ask you to do on this one is to make sure you write your c squared first. That makes it a little bit easier. Otherwise, you just have to flip the sign at the end, which I always get confused. So a triangle has side lengths 6, 11, and 14. Is it acute, obtuse, or right? So let's just start it. So we know this one has to be our C. And we'll call this A and B. Now remember, you're going to write it backwards. 14 squared equals 6 squared plus 11 squared. So that would be 196 equals 36 plus 121. Okay, we're going to go ahead and add over there on the right. So that would be 196 equals 157. Are they equal? No, so it's not a right triangle. Okay, 196 is greater than 157. So since it's greater than, it will be an obtuse triangle. If it was less than, it would be acute. All right, the next one, same thing. Let's make this my C. That'll be your A and B. So I'm going to write it backwards. 9 squared equals 7 squared plus 8 squared. 81 plus 49 plus 64. 49 plus 64 is 113. So now 81 is less than 113, so that would be less than would be an acute triangle. Okay, so that is it for section 8.1. Sorry this video was so long. Hope you enjoyed watching.